Let's consider 2 points in space named A and B, and let's also assume that this person wants to travel from A to B. Sounds simple, right? Let's zoom into this a bit. Our stick figure will reach a point C on its journey towards point B. This point C is the midpoint between point A and point B. Then it will reach a point D, which is between C and B. Then E, F, G, and so on. The distance gets smaller and smaller, but there will also be an infinite number of midpoints. So a stick figure will never reach B. This is what a Zeno's paradox is. It's a theoretical thought experiment where an object cannot reach its destination because, logically speaking, the object will have to travel an infinite number of segments to reach its destination. But this is a solved paradox. Let's look at the solution in detail. First, let's look at the mathematical arguments. If we consider the entire space between A and B as a square and keep halving it infinitely, as shown in this image, what we will get is a mathematical series called convergent geometric series. This effectively means even an infinite segments of a whole, when summed together, will all add up to the whole. So the destination B is a finite point in space and hence is reachable. But what about time? We can argue that as the distance gets halved repeatedly, the time to cover it should reduce as well. But this might be hard to prove if mathematics is the only tool we had. This is because, considering the argument that time decays, at each point the estimated time gets smaller and smaller. But this decay will be a divergent harmonic series, as we see in this plot. This means the summation will have no upper bound and will keep reducing at a very small rate forever, as in the first midpoint would have taken half of the total original time to reach, and the next one would have taken one third, and so on. This is where we reach an interesting place. What if it is not about the time or the distance? What if we consider the rate of motion? Switching to physics, we can say the vector velocity is the rate of change of displacement in a specific direction. The average velocity remains constant because by Newton's first law of motion, objects in rest remain at rest and objects in motion remain in constant motion unless acted on by an outside force. So, we can prove that the time to reach point B actually reduces as the displacement happens and has an inverse correlation with displacement. Further, we can also prove that a finite point in space can be reached in a finite amount of time with a finite velocity. The keys here are the rate of change of speed and position in a space-time continuum. This also correlates with what we got from our mathematical model of a converging geometric series, the square which we saw earlier. Thus, we can prove that we can reach point B just by using mathematics and physics and without getting into any philosophical contemplation to solve this paradox. This is the explanation of the solution to the Zeno's paradox.